We're going to look at factors and multiples of whole numbers to introduce this unit. So for us to do that, we just need to go through a bit of terminology. So I've written out the notes for you. You can write this out and then just sort of listen along. So natural numbers, when we refer to natural numbers, we're talking starting with the lowest number of natural number would be 1, 2, 3, 4, 5, 6, and it would continue. It's simply, if you were to learn how to, when you first learned how to count, we would teach a child to count by just starting with 1, then 2, then 3, then 4. We don't talk about the decimals, fractions, negative numbers, and in fact, we don't even introduce 0 right away. If you think about teaching a little kid to count, we start with 1. So that's what we're referring to with natural numbers, and that pattern, of course, would continue infinitely to the right. Infinitely meaning forever to the right. Whole numbers is the same idea, except that 0 is now included. So when we refer to the whole number system, we're talking about 0, 1, 2, 3, 4, 5, 6. So again, no negative numbers yet, no fractions or decimals, right? So when we're talking about these two, we'll look at other number systems later, but that's what those two refer to. Now, a prime number, if you recall, is a natural number. So that's why we defined what that is. So it's got to be a natural number. So 1, 2, 3, 4, etc., with only 2 distinct or different factors. So 1 and itself. So for example, 2, 1 times 2 is 2. Those are the only factors of 2. Factors meaning what multiplies to 2. 3, 1 times 3 are the only 2 numbers that multiply to 3. 5, 1 times 5 are the only 2 numbers that multiply to 5. Same is true for everything in the list. Now, of course, this list continues, but here's our smallest sort of prime numbers. Composite numbers. So what's a composite number? It's a number with 3 or more factors. Basically, if it's not a prime number, it's a composite number. So for example, 4 would have the factors 1 times 4 and 2 times 2. So factors of 1, 2, and 4, so it has at least 3. 6, factors of 6 would be 1, 2, 3, and 6. All of those numbers are divisible by 6 is another way to think about that. 9 as well, 1 times 9, 3 times 3. All right, so that's more just to distinguish the difference between prime and composite numbers. So what we're going to be looking at in this lesson is something called prime factor. So what's a prime factor? It's a prime number, so one of these from the list, that is a factor of a given number. So let's look at an example because that helps really understand it much better. So 5, which is a prime number, is considered a prime factor of 30. So 5, it goes into 30, or 30 is divisible by 5. And yeah, but 5 itself is a prime number. Okay, so what we're going to learn is what prime factorization is, which is basically to list the prime numbers. So we're going to write a number as a product of its prime factors. Product, remember, means multiply. So let's do this example together to show you what I mean. Okay, so for example, let's say we have the number 20. So write this down along with me. You can pause the video at any time if you need to slow down or rewind it. I want to split 20 into 2 numbers that multiply to 20. I have a couple options, but the first thing that came to my mind was 4 times 5. So we have this factor tree, we call it. Okay, 2 and 10 could have been another choice, and that would be another way to do this. So 4 and 5, when I look at that, 5 is a prime number. I cannot break that down into other factors. 4, however, can be split down into 2 and 2. Okay, so what this means is if I was to take 2 times 2 times 5, I would get 20, right? 2 times 2 is 4, 4 times 5 is 20. So that is the prime factorization of 20, or we call this the product of prime factors. This can also be written as 2 squared times 5, because 2 times 2 is 2 squared. Now, I think it's worth mentioning, if any of you right off the bat were thinking, I was going to write 2 and 10, I want to show you that doing a factor tree with that would also be acceptable. 2 does not break down, it's a prime number. 10 has factors. We can split that up into 5 and 2. And you look, our tree branches are the same. We have 2 2s and a 1 5. So I still get 2 times 2 times 5. So you'll get the same answer even if your factor trees have different factors within them. Your bottom branches will still be the same.